Hello again. This video will show you the basics of multiplying polynomials. Example 1. We got a monomial being multiplied by 1, 2, 3, 4, a 5-term polynomial. Basically, this is one big distribution. So 2x cubed times x cubed gives you 2x to the 6th power. X cubed times x cubed is x to the 3 plus 3. 2x cubed times 3x squared will give you a positive 6x to the 5th power. And a 2x cubed times a negative 2x will give you a negative 4x to the 4th power. And a 2x cubed times a positive 5 will give you a positive 10x cubed. So we still end up having 1, 2, 3, 4 terms. Our leading coefficient is a 2, and our highest degree is 6. So this is a 6th degree polynomial. Example 2, we're going to find the product, but we're going to do this vertically, and one of the reasons we do that is because we have a binomial here and a trinomial here. I like to put the trinomial, which has the more numbered terms, on the top. So what I'm going to do is put my 3y squared minus 6y plus 5 on the top, and then bring my 2y minus 3 underneath it. Draw my line, put my little time symbol here. And all I'm going to do is take this negative 3, multiply it with my 5, and I get negative 15. Then I'm going to make take my negative 3 and times it by my negative 6y, and I will get a positive 18y. And I'm going to take my negative 3 and I'm going to times it by my 3y squared, and that will give me a negative 9y squared. I'm going to go ahead and take my 2y and I'm going to move over one space, just like putting a 0 there. And I'm going to take my 2y and now multiply it by the positive 5, and I'll get 10y. That's a positive 10y. And my 2y, multiply it by negative 6y, and I get a negative 12y squared. And my 2y times my 3y squared, and that will give me a 6y to the 3rd positive. All I got to do now is draw a line here and add these up vertically, and I'm going to start on the right hand side. So negative 15 plus 0 is negative 15. 10y plus 18y gives us a positive 28y, and a negative 9y squared plus a negative 12y squared will give us a negative 21y squared. And I have no y cubes to combine up here, so 0y cubed plus 6y cubed leaves me with 6y cubed. And I end up with a 4-term polynomial with a leading coefficient of 6 and a highest degree of 3, so a 3rd degree polynomial. This next technique is show you how to do this horizontally. I'm basically going to take this first term and show it as a multiplication next to this, and then rewrite this second term with a multiplication next to this. So I'm going to start like this: 2y times 3y squared minus 6y plus 5. Bring over my minus 3 and show that 3y squared minus 6y plus 5 inside parentheses. So what I will end up having is two large distributions, and notice that what's in parentheses here is identical. So I'm taking the first trinomial and I'm distributing each term of the second binomial to the entire trinomial. Okay, so go ahead and multiply it out. We should end with the same answers we did on the previous page. 2y times 3y squared gives you 6y cubed. 2y times a negative 6y gives you a negative 12y squared. And a 2y times positive 5 gives you a positive 10y. Now you have to be careful on this next one. You have a negative 3 that's being distributed, not just a positive 3. So a negative 3 times a negative 3 would give you a negative 9y squared. Negative 3 times negative 6 give you a positive 18y. And a negative 3 times 5 will give you a negative 15. Now, in order to make this look like we did in the last page, is we have to combine our like terms. I'm going to find all of my cubes, which I only have one, which is 6y cubed. I have a negative 12y squared and a negative 9y squared. That combines to make a negative 21y squared. I have a positive 10y and a positive 18y, which combine to make a positive 28y. And I don't have anything to combine my constant value with, so it just trails as a minus 15. For example 4, we're going to use another method called using a table. For those of you that pay attention during science, you might notice that this looks very similar to a Punnett square. All we did was take this trinomial and put it in 3 columns, 1, 2, and 3. In the binomial, we put it in 2 rows, but we're still going to do a multiplication just like we did before. So the first thing is going to be the 2y times the 3y squared, and that will give us 6y cubed. And then we're going to take the 2y and times it with the negative 6y, and that will give us a negative 12y squared. And the 2y times the 5, and that will give us a positive 10y. And then we're going to repeat that same process, but we're going to do it with the negative 3. So negative 3 times the 3y squared gives you negative 9y squared. And negative 3 times negative 6y will give us a positive 18y. And the negative 3 times the 5 will give us a negative 15. Now, when you go to put these back together, you start by looking for your largest exponents, which would be this one right here. So we bring down our 6y cubed, because there are no other cubes in the problem. So I'm going to just go ahead and cross that one off so I don't get distracted by it. So the next number down from a power of 3 would be a power of 2, and you see we have 2 of them right here and right here. So that would be a negative 9 minus 12, which would give us a negative or minus 21y squared. So these two are actually done. Then we look for the regular y's, which we have here and we have here, and that's both positive 18 and 10, so that would give us a positive 28y. These two are done. And the only thing left is the negative 15, which I'm going to attach with a minus 15. And if you do it all correctly in that order, you'll end up with the same 4-term number that we had in the previous problem. Example 5, we're planning to build a walkway that surrounds a rectangular garden. If you look at the picture on the side there, you can see what it looks like. The width of the walkway around the garden is the same on every side. So that means that this over here is also x feet, and this up here is x feet. Write a polynomial that represents the combined area of the garden and the walkway. We want to find the area. Well, area, this is pretty much a rectangle, so area is going to equal length times width. So all we got to do is figure out what the length and width are in terms of an algebraic expression. Okay, so we'll call this length and we'll call this width. Okay, so how far across is this? We have an x here, we have an x on this side, so together that makes 2 x's. But I also have plus 10 feet across the middle. So the actual length of this is 2x plus 10. Now to find the width, we have x here, and we have x up here. So that's also a 2x. And I have the distance in between, which is 9. So add 9 to that. And that's going to be my length, and that's going to be my width. And in order to find the actual area, we're going to multiply those two together. So I'm just going to leave them as they are, and I'm going to use the vertical multiplication technique. So 9 times the 10 will give us 90. 9 times the 2x will give us a positive 18x. Fill in a 0 here when I go over to do my 2x. Now 2x times 10 is going to give me a positive 20x plus 20x. And then the 2x times the 2x is going to give us a positive 4x squared. Draw my line and add those together. Now what I'm going to do is I'm going to take that result and add them at the top. So the 4x squared has nothing to combine with, so that's just going to be 4x squared. I still have a 20x plus an 18x, and that makes plus 38x. And then I have the 90 plus 0, which is just plus 90. So this expression right here actually represents the total area of the garden. Now they want us to find the combined area when the width of the walkway is 4 feet. So what they're saying is this x value is going to be 4. So in order to find the total walkway or combined area of the walkway, we're just going to substitute x with 4. So we're going to take our expression up there and substitute 4 in place of everywhere we see an x. And I think that's in feet. Yes, it is in feet. Plus 90. And use a calculator here and make sure you follow PEMDAS. So I need to do my exponent first before I times it with the 4. So 4 times 4 gives us the 16, and then times the 4 out in front. So this whole calculation here gives us 64 feet plus 38 times 4 will give us 152 feet for this one. This is square feet, so 64 and 152 square. And I just have a constant value of 90 at the end. So add them all together, we get the 64 plus the 152 plus the 90, and we end up with a total of 306 square feet. So this ends up being the total combined area of the walkway along with the actual garden itself.